Cancer, metastasis, lymph nodes, patients, tumours. These are all words we were using over and over again during our research. It's easy to forget their actual meaning, their significance when put in context of lives like yours and mine. That's why my group and I thought I should share my own story, what the meaning of cancer is to me. In truth, that one tiny little stupid word, it's hard when it comes too close. It means exhaustion, emptiness, silence, and uselessness. On March 15th, 2 days before his 13th birthday, my little brother was diagnosed with cancer. Stage 4 anaplastic large cell lymphoma. Despite only being able to FaceTime him in hospital, we noticed the spreading, the swollen lymph nodes appearing around his groin, his neck, his armpits. Immediate chemotherapy was the only path he could take, and I can tell you, it's not a pretty path. As he goes into his 6th and hopefully last round, we can only hope that the lymphoma has been conquered, that it doesn't return, that it doesn't spread to his lungs or liver. Metastasis causes about 90% of deaths in cancer, yet very little is known about its underlying mechanisms. There aren't any drugs that target metastasis. That's where my motivation came from whilst doing our project. I want to feel a little less useless than I did when I got the call from my father telling me the diagnosis. At the time, I didn't even know what metastasis meant. Now I'm using coding in R, running statistical tests on TCGA data. So maybe now you're wondering, what exactly is metastasis, and what have we been researching about it? Well, let me first hand over to this little animation we've created.
You guys probably already know what cancer is. Uncontrolled cell growth as a result of an imbalance between the process of cell death and cell growth. But what's metastasis? In the later stages of cancer, it spreads from the primary tumor to another organ or tissue in the body. It's responsible for about 90% of cancer deaths. But we currently do not know how the tumor manages to do that. How can we find out more about what happens during metastasis?
To answer this, we looked at the tools or rather the gene sets which are expressed by the cancer cells during the process of metastasis, and thus could give us insight into the cell processes that are taking place. Other works have already made the epithelial mesenchymal transition gene set and the oxidative phosphorylation gene set a candidate for being correlated with metastasis. In order to identify other potential correlations and to confirm the findings for EMT and OXPHOS, we looked beyond those two pathways. With data from the Cancer Genome Atlas, we were able to analyze hundreds of primary tumor and metastatic tumor samples across many cancer types. Using statistical tests, we compared the RNA expression levels of metastatic and non-metastatic tumor samples for each gene set and looked for significant differences. Let's look how far we got.
Okay, Levente, do you want to share your screen and show us what you have?
Oh, sure. So I always get the same error and I don't know what I'm doing wrong, but I could show what I'm doing. So let's install the packages. And I'm going to read in the data. And now I wanted to loop over all these cancer types that I selected. And I'm getting the same error over and over. Says that the object cancer type is not found, and I don't know what I did wrong because I have defined it as a vector here. So maybe someone could help me out.
That is kind of weird, but I also had an error. I think maybe you should have done some typos somewhere, like commas, apostrophes, maybe S's. I don't know.
Yeah, or maybe sometimes like when you leave out the brackets, it's not working too.
Yeah,
So
the
maybe.
brackets errors are shown normally on the left side.
Oh
so-
yeah, right. Yeah.
so-
Yeah, I think it's the S at the end of.
Oh, yeah.
Oh yeah, right.
We're missing an S.
There, oh, here at cancer types. Oh yeah, now it should be working. I'm gonna try it again. This is gonna take a while.
Can I go and make coffee in the meantime?
Yeah, sure.
Oh, there. I think it's.
Oh, yeah. I think you
Okay,
can go
so
on.
let's do a heat map that shows us our results.
Oh yeah,
Oh,
that was
gosh.
nice.
Beautiful.
Looks amazing.
Wow. I think that it's time for us to explain this heat map now, isn't it?
Yeah,
Okay.
explaining what these results really mean.
This heat map displays a great representation of the cancer types and the gene sets that are associated with metastasis. Through the dendrogram on the left, it is noticeable that the cancer types are grouped based on their similarities with respect to their specific gene sets. Pancreatic adenocarcinoma, kidney carcinoma, skin cutaneous melanoma, and other cancer types that are grouped in the last branch of this dendrogram do seem to have a pattern. However, one outlier that can be easily distinguished is the thyroid carcinoma on the first row of the graph, where coagulation and KRAS signaling up gene sets are highly positively correlated to metastasis. Meanwhile, oxidative phosphorylation gene set indicates a negative correlation. What I found fascinating was the difference in correlation of glycolysis gene sets and oxidative phosphorylation gene set with metastasis on the cancer types. Metabolic activities in normal cells rely primarily on mitochondrial oxidative phosphorylation to generate ATP for energy. Unlike in normal cells, glycolysis is in haste and OXPHOS capacity is reduced in various cancer cells, as shown in the first rows of our results in the heat map.
The goal is to in the future find a drug that can specifically target cancer cells based on the mechanisms and pathways that we find to be correlated with metastasis to prevent further spreading of the tumor. Thus, surgeons could operate upon the primary tumor. If we manage to do so, cancer patients could have a chance of a normal and healthy life.
The greatest of our thanks to our mentor, Michael Thaler, for inspiring us, supporting us, and being our guide in this project that brought out the best of us. To the Thyroid Lab, to the coordinators of this magnificent program, Aya, Dorit, and Nirit, for giving us the confidence to face our curiosity and make us feel at home. And finally, to the Weizmann Institute for giving us the opportunity to dabble in science with such talented and brilliant people. Thank you all.